In this video, we're going to take a look at using a conjugate to rationalize the denominator of fractions. So what is a conjugate pair? Well, you've seen them in your factoring section. A conjugate pair looks like a plus b times a minus b. And when we actually multiply that out, we know that we get a squared minus b squared. Okay, so why do we need to rationalize the denominators of fractions with conjugate pairs? Or why do we even need to rationalize them to begin with? Because it's easier for me, number one, to say, I really don't know what this is. But if I rationalized it by multiplying by radical 3 over radical 3, I would get 2 times radical 3 over 3. That means I'm going to be taking 2/3 of radical 3, and I know radical 3 is going to be somewhere around 1.7 or 1.8. So it's much easier for me to think of 2/3 of 1.7 or 1.8 than it is for me to think of, wow, what is 2 divided by 1.7 or 1.8? That I can't do as easy in my head. So it's easier to have the radical in the numerator. So why do we need to use conjugate pairs in our denominator? Well, what happens if we have something that looks like this in our denominator? We'll need to get rid of that radical. So how do you get rid of it? You would get rid of it by multiplying it by its conjugate. Its conjugate, if you notice up above, the conjugate consists of the same two numbers, but in the other pair it has an opposite sign. So here I'm going to have radical 2 and a 3. In this one I had a plus, this one I'm going to put a minus. So now when I distribute radical 2 across both of these two terms, I get the square root of 2 times 2 minus 3 square root of 2. And when I distribute this last term across both of these, I get 3 plus radical 2 minus 9. And I want you to notice the two inside-outside terms reduce. And this first radical, because I have a group of 2, becomes a 2 minus 9, which is just a negative 7. The radical is eliminated. So when we multiply by a conjugate, we can eliminate our radical. So let's first start off by finding conjugates. So again, when I find a conjugate, I'm looking for the same two terms, but they're separated by the opposite sign. So for this one, the conjugate pair, I'm going to have a 3 and a radical y. But instead of putting a minus here, I'm going to put a plus. It has to be the opposite. Here I have 2 radical 5 and minus 3 radical x. So the conjugate is going to have 2 radical 5 and 3 radical x, but instead of the minus, it's a plus. For the next one, we're going to start off with a radical y and a 3, but instead of a plus, we're going to put a minus here. And for this one, we'll start off with a 2 and a 4 radical 7. Instead of the plus, we'll put a nice minus here. So my conjugates look like this. Same two numbers, opposite signs. So those are my conjugates. So let's move on to rationalizing the denominators now. Okay, so we're going to use the concept of conjugates to get rid of our radicals. So we're going to find the conjugate of our denominator, and remember, when we have fractions with binomials, we add our parentheses. So what is the conjugate of my denominator here? Well, the conjugate is radical 11 and a 2 here, but we're changing the sign from a plus to a minus. radical 11 minus 2. And remember, we have to multiply by the number 1, or else we change the value of our fraction. So I multiply by the number 1, so I'm not changing the value. So in the numerator, I have to distribute my 3 radical 11 minus 6. And in the denominator, I'm going to distribute my radical 11 first. So I get radical 11 times 11 minus 2 radical 11. When I distribute this last term, I get plus 2 radical 11 minus 4. And if you take a look at this, these terms reduce out. So when I simplify, my numerator does not simplify because 11 is prime, but my denominator has a group of two 11s here. I get 11 minus 4. What is 11 minus 4? 11 minus 4 is 7. This is my final answer. All right, so this problem is very similar to number 5 and number 9 on your worksheets. So let's try another one. We will multiply by the conjugate of the denominator. Again, add your parentheses. Radical 3 and a 7. This guy here has a plus, so my conjugate's going to have a minus. Radical 3 minus 7. So when I multiply by radical 7, I'm going to distribute. I'm going to get radical 21 minus 7 radical 7. Okay, my radicals were the same for these first two, so I could multiply what's underneath. Now I'm going to distribute my radical 3, so I get radical 3 times 3 minus 7 radical 3. When I distribute this positive 7, I get plus 7 radical 3 minus 49. Those inside and outside terms should always cancel out. So we have our minus 7 radical 3 and our plus 7 radical 3. 21 is just 3 times 7. There's no group of 2, so that stays the same. But I do notice I have a group of 2 3s here, so I pull one of the 3s out. 3 minus 49. And what does that equal? When I take 49 away from 3, I get a negative number. And I shouldn't leave a negative number in my denominator, so I'm going to take this and multiply the numerator and the denominator by a negative 1. So when I'm done with this problem, I get a negative radical 21 plus 7 radical 7 over a positive 46. So I'm done with that one. This problem's a lot like number 7 on your worksheet. So again, we're rationalizing our denominators. We have a binomial in the denominator and in the numerator. So I'm going to find the conjugate of the denominator. So I'm going to start off by writing radical 3 and radical 2 because that's what is here in this. This one has a plus, so I am going to put a minus in mine. So again, I have to multiply by the number 1, so this fraction has to equal 1, or else I change the value of my fraction. So now I have a binomial, a FOIL in the numerator. 6 times radical 3 is 6 radical 3. 6 times negative radical 2 is negative 6 radical 2. And now I have to multiply my radical 3 out. Radical 3 times radical 3 is radical 3 times 3. And radical 3 times negative radical 2 is negative radical 3 times 2. So let's go ahead and multiply our denominator out. Radical 3 times radical 3 is radical 3 times 3. Radical 3 times minus radical 2 is a radical minus radical 3 times 2. Radical 2 times radical 3 is a plus radical 3 times 2. And radical 2 times minus radical 2 is radical minus radical 2 times 2. So my first term doesn't simplify, my second term doesn't simplify, but I do have a group of 2 here, so I can pull that out. 6 radical 3 minus 6 radical 2 plus 3. I pull one of those 3's out, minus radical 6. I don't have a group of 2 there. And then I have a group of 2 3's in the first one, so I'm pulling one out. I notice that minus radical 3 times 2 and plus radical 3 times 2 are the same terms. And now I have a group of 2 2's, so I'm going to pull one of those 2's out, minus 2. And when I reduce the numbers in the denominator, I just get a 1, so I just have my numerator left. So that's a lot like number 7, number 8 here. All right, so again, I'm going to start off by putting parentheses around my binomials. Okay, and then I'm going to identify my conjugate. This one has a minus sign, so we will use a plus. And I have to multiply by the number 1. So let's go ahead and distribute. So I get radical 2 times A times A plus radical 2AB. Let's distribute the second term. I get positive radical B times B. Or, oh, I missed something. Whoops. Plus, I have to multiply that first term. Radical 2AB plus radical B times B. Now, what happens when I multiply my denominator? I get radical 2 times A times A. I get plus radical 2AB. Okay, minus radical 2AB. And then I get minus radical B times B. So what do I have all together? Okay, so I want you to notice that in my denominator, the inside and outside terms reduce again. I have a group of 2 2's and 2 A's and 2 B's, and I have like terms in my numerator. I must add those. So I'm going to pull out a group of 2 and the group of A. When I add radical 2AB plus 2AB, I get plus 2 radical 2AB, because remember I have the number 1 in front of those, so I add the numbers in front, and then I'm pulling out a group of 2 B's, so I get plus B. In the denominator, I have a group of 2 2's, a group of 2 A's, and a group of 2 B's. So what do I get in the denominator? I'm pulling that 2 out and the A out, minus B. That is going to be my final answer. And that's a lot like problem number 8. And do we have time for this one? We do. Let's walk through this very quickly. My conjugate is going to be 2 plus radical 6. And again, we have to multiply by the number 1. So when I distribute a negative 12, I get a negative 24 minus 12 radical 6. And when I distribute the 2, I get 4 plus 2 radical 6. When I distribute the negative radical 6, I get minus 2 radical 6. And then I get a minus radical 6 times 6. I notice in my numerator there is nothing to reduce. But in my denominator, I notice these terms reduce out, and they should always reduce out. And I have a group of 2 6's in my last term. So I get 4 minus 6. So now I have negative 24 minus 12 radical 6 over 4 minus 6 is a minus 2. So I notice that all of my numbers, negative